introduction, and my name is Chishima of NEC. And thank you very much for giving me this time to present this. The first brief introduction myself. I have been working with or for NEC. In 2016, I was seconded to the Cabinet Office, and there, for 2 years and a half, I was promoting a variety of technologies, science technologies, and one of them was the quantum technology. And with that experience, in 2018, when I returned to NEC, I joined the quantum science team. And for 5 years since then, I've been doing the application exploration, trying to see which applications this quantum computing fits. And with that experience, today I want to share with you what I found. The NEC working in the quantum technologies, and what kind of quantum technologies we are working on. Obviously, quantum computing technology, which I'll talk about later, but not limited to that, about the quantum communication and quantum cryptography, and also quantum sensing technology as well. So NEC is aware that and understands that this quantum technology brings a huge impact to our society. So that's why we're working on these areas. And this quantum computer technology, some of you may not be familiar, but the NEC, it turns out, has been developing this technology from the 1980s or even before. The first major outcome came in 1999, you can see, and was published at Nature magazine. We confirmed the solid-state devices, and with that as a trigger, we've had constant research work in around 2010, and pseudo quantum or quantum-inspired technologies, supercomputer units to solve the maximization of combination. And we released that solver, and for the future, for quantum annealing and further down, and quantum gating in computing are the technology areas we are working in our R&D. And also, from software perspective, it turns out for the last 5 years, in preparation for the future quantum computing to be widely used, we are using the pseudo quantum platform to prepare for that, and making sure that such software will be viable for actual quantum, or use both the pseudo quantum and the actual quantum bits. So for that purpose, we feel we need a middleware for that, and which we are also working on. And this is the outcome of our research so far. And in both cases, annealing is the topic. And in the project supported by NEDO, and we have superconducting quantum annealing machine we developed. And even though it is only 8-bit, we have confirmed the basic functions and behaviors of such machine. And on right-hand side, and this real annealing machine it has the same interface, but it can be implemented with the supercomputer as well. And we have this service already available. And currently, we are bringing actual customers' issues and applying this and providing this as a solution. So this quantum pseudo-telepathy is a technology we are starting our solution with in this area. And most recently, I'd like to share with you, we have a joint research again. And the actual quantum and pseudo-quantum both can be processed by working with Tohoku University, and what architecture should be there to be able to have this hybrid processing. And we have formed this collaboration and started working on this. So we are very looking forward to its outcome down the road, and hope you will too. And from here, using a few slides, how we are working with the actual customer issues and challenges with quantum annealing. And actually, the result is used daily by our customers. And first, under the NEC Fielding Company, we came up with this solution. And this is targeted at the maintenance component distribution for logistics area and how to bring efficiency to the distribution and delivery planning with computing. And this problem is targeting at the area of Tokyo area, about 400 vehicles in the fleet to make distributions and deliveries. The plan has to be put together the day before in the evening. And in the past, experienced planners put together a plan for the following day. And only the few experts can put such a plan. If they are not available for some reason, then they cannot do that, and they had to do that in the after the work on the previous day. So that was not easy. And it is somewhat different from the optimization of the logistics routing, but for maintenance parts, and typically both the component and the engineer or repair engineer has to be available at the site at the same time. And there has to be repair engineer and the repair component. Both needs to be available. And in Tokyo metropolitan area, if we have to do that, we need to be a little bit creative to make that happen. That is, if it's in the rural side, and typically one truck will have engineer and the component together, and then go to the customer site and replace the component and move on to the next customer. Very simple. But in Tokyo area, when you're repairing at the customer site, you cannot park the truck by the roadside. And so engineers has to use a public transportation, and the delivery of the component has to be made just in time at the customer site when the engineer arrives. So conventional approach was not available in the market, was not viable. So we use this model and run this model, and typically the experienced planners spend two of them spent 2 hours and a half. That can be solved in 12 minutes. And the quality was very comparable. And so that's what we have confirmed. And also, because this is this approach, there was no mistake. And if the human work is involved, sometimes very simple error or mishaps might take place, but that is avoided. And you can see 30% improvement. It turns out that that is expected if we incorporate what we are working on right now. That is that in addition to the planning for the following day, there is sometimes a request for emergency delivery on the day. And how can that be merged into the pre-prepared plan from the previous evening? And if that happens, we believe we can improve 30%. And another topic involving NEC group company called the NEC platform. In the production line of a factory, this problem is how to efficiently put together a production plan. As you know, that the mass production is a thing of the past in any factories. In each line, a whole variety of products are produced in a mixed manner. It's on the one single production line, constantly changing the production setup to produce a variety of products. That's the challenge shared by many manufacturers. And we believe what we come up with can be applied to many other plants. And while you're changing the setup of the manufacturing line, obviously the production is stopped. So how you shorten the setup change really impacts the overall performance of the factory. For example, if one line produces 30 different products, that means 29 changes. Now, if you simply do one at a time, it could take a long time, but you can optimize that by changing the order and so on, and that's what we want to solve with this. And in this case, once again, that the simple condition can be accommodated with the existing solver, or there is an existing optimizing solution. But it turns out for each customer has different restrictions and constraints. In this case, for example, there are kind of a pairing of two products, or prohibition of one product must not be made produced prior to another type of product. And this kind of restrictions cannot be accommodated by existing solvers, but this type of solution has been accommodated traditionally by expert spending 1 hour or so, but now it can be planned in 10 minutes. And altogether, this transition time have been halved. So that bringing a huge impact to the productivity of the plant in this particular company. And they started this initiative. They have introduced that approach. They want to introduce to 4 other Japanese plants and eventually to the factories outside of Japan, because the manufacturing or production planning in the past has to rely on the experienced planner, who may be available in Japan, but it's difficult to have those experienced planners outside of Japan. Even if you do develop such an experienced planner, he or she may move to another plant and companies. So this kind of solver would have a huge merit. And another initiative is to apply this to the natural disasters, more of a kind of a public needs. And in collaboration with the Tohoku University, we have worked on this. When a huge earthquake takes place and tsunami is taking place as well. And on left-hand side, you see the outcome from the supercomputer indicating the inundation caused by tsunami or flooding caused by tsunami. And then on the right-hand side, what would be the optimal evacuation routes? And obviously, the shortest path is the best, but that may cause congestion, and thus taking more time. And there's a lot of technology involved to identify different routes, candidate routes, and which one is to be selected is so selection and combinational optimization is where the quantum computing is used to get the optimum route or routes, and that's our research here. So I've introduced some of our application areas in the last 5 years. We have worked with different companies in different industry segments and exploring the viable applications. And we came up with a very promising application candidates as well in different domains. And this combination optimization, combinatorial optimization could work a lot. And there seems to be areas in the past IT vendors were not tackling at them. And this new technology made us realize there were a lot of other opportunities like that. And that is one of the major contribution of our research effort. So we are about to launch many application areas, solutions. And two examples I talked about the production and the logistics. And you might have noticed in both cases, the experts in the field, we wanted to reduce the burden on them. So that's one direct value we can provide. But if it is limited, we can only save the salary of those people involved. But as we interact with our customers, we realize that this technology has much more value than that. By that I mean, for example, in the case of distribution, logistics, and one day's work was assigned to a truck, and delivery was made successfully. And if we have the data, now the following year in 2024, if there is a major change, the logistics, let's say overwork, has to be controlled, so-called year 2024 issue in society. And when that should happen, with existing business resources, people and trucks, delivery trucks we have, we can simulate whether we can actually fill the need of distribution and logistics. And if we are short, we can simulate and identify what type of trucks we should obtain. And we can actually check what-if scenarios. And also, we don't need to worry about the restriction of the expertise availability in the field. So we not only lighten the burden of the experts in the field, but also whole business can be optimized and made more efficient. And in this case, if when we analyze, it turns out in the morning it's more congested. If we can move some work in the afternoon, we can level the workload for the system. And where should we do that? And maybe we can combine that with discount, and thus leading to a new proposal and making the business or improving the business much better. For example, in manufacturing, if there is an urgent production order came in, request came in. Now, in the past, we have to go to the field people and go back and forth and see, and it may take a few days before we can respond to the customer. And the customer may not be able to wait, and they may find another means. Now, with this kind of a solution, the management can make the judgment of whether we can take that emergency order or not, and if needed, what adjustment we need to make, and what order may has to be pushed to the next day, and this kind of a judgment can be made. So that's all I wanted to share with you. And we don't have a Q&A time allocated, but we do have a booth. Please stop by at the booth so that if you have questions, we should be able to answer your questions. Okay, thank you very much for your attention.